You'll find with your Harbor Freight spot welders, the weakest spot is the switch. It causes you to lose current, which pulls current away from your tongs, making the weld less controllable. Now to fix this, I wanted to come up with a way to have a foot switch so you don't have to have your hand on here and pushing the switch at the same time, adjusting the tong pressure, because that's obviously crucial to your weld. My brother came up with using a motor start relay, a scrap piece I had around. It's a 8 horsepower motor start relay, and we mounted it into this box, this old fuse box. And basically what that does is enables me to have a foot switch and a much higher quality switch, to where I'm not losing any current when I go to weld. Another modification I made was I put an SCR on here to control the current, to be able to adjust it higher or lower. These together have really made this machine a lot more useful. Also, we got rid of the original switch, just wired across it. Now I'm going to go over a couple basics of spot welding. Make sure your tips are nice and clean and that they cover evenly. A lot of times I'll put my 2 tips down together and run a file between them. Make sure that they're touching evenly. Alright, next we're going to line up the rails with the trunnion. Usually I just stick a couple rivets in there, make sure everything's sitting good. I usually take one side out so that when it's sitting in there, I won't have the rivets falling out. You're going to have to fit that usually anyway, a little bit to the trunnion. You kind of file around, so that's pretty crucial, but you don't want to put those rails so tight in there that it barely fits. But we want it, one of the advantages of using a flat instead of a pre-made receiver is that you can get these rails really fitted to the receiver and the trunnion. What I do is I just kind of roughly measure and mark with a Sharpie where I'm going to put my welds at, and then you can use a depth gauge maybe to help you get them straight along here, whatever works for you. To clamp the rail in, I just use a regular old C-clamp and a little piece of aluminum that I had sitting around the shop. Any little block, it could be out of wood, whatever. That's just so when you sit this in here with the C-clamp, it'll be able to clamp onto the aluminum instead of this little skinny rail here. 15/64 usually is the size that this is, but I'll lay whatever drill bit is the size of the top of this receiver rail down to this lower rail, to where that will line up square with this lug. This one over here is not a lug, that's for the feed ramp, goes up against that, but just whatever makes these rails even with that trunnion. So make sure your holes kind of line up, eyeball them. I usually put the rivets in and out both sides so that I can make sure that it fits good, and then clamp it down. You should be good to go. Okay, and this shows you just the setup. I got the drill bit laying in there, rail butted up against the trunnion. You can leave a little bit of slack in there if you want. I usually like to get mine pretty close. Make sure your holes are all lined up. I stick my rivets in there so they come in and out really easy. This should be flush too. And I make it loose enough though to where you can get your drill bit back out. We don't want that being a heat sink, and you don't want to heat your drill up, even though you're not really putting much heat on there, but it just kind of gets in the way anyway. So just kind of slide it out. Get it out of the way. I've marked the top of mine. Really this way, it still looks pretty good if they're not really even. Up and down seems to give you a little bit of ugliness. That's just kind of a rough thing that I do, just layout, whatever works for you. I kind of just eyeball it. A lot of guys want theirs to look perfect, So you could use a depth gauge type thing. Sometimes I'll use that. I usually take the front trunnion out as well. Okay, and we should be good to go to start spot welding. First we're going to do the right rail. I usually do it first because it doesn't really hold as much strength as the one with the ejector, the left one. It's going to have to kick that shell out. So I see it as an advantage to get your practice run really on this one. And then once after you're warmed up, do the one that really matters. The other noise you hear on the tape is the kiln heat treating another receiver. It's not the spot welder. Sounds somewhat similar, but also listen for when I kick it on, you'll hear a nice click, and that's our switch from our foot switch here. See, the method I use is to kick it on and let it turn orange, and then kick it off, let it turn orange again. So I heat up the metal slowly. Seems like if you go too fast, it almost overcooks it. So that's the method I use. They seem to be pretty strong. I've strength tested them before. And seems to give you the best nugget. So that's looking pretty good. I usually get these two front ones done, and then I'll move my aluminum block back a little bit, and then do these. Like when you run anything else, there'll be a little tiny bit of slack as you move back. So I kind of keep my block on there until I get most of the rail welded, and then you're fine. Because you really don't want these tongs to be the one pulling the pieces together. That'll cause arcs, and it just won't weld right. So always have a clamp or something in there to make sure that they get held down properly. Okay, another thing I'd like to note is I go up to the rail and then I kind of just scoot it back just a little bit so that the rail isn't soaking up any of our heat and that we won't arc against it. So I'm going to do another one here. Also, another thing I do to make sure they're all in line is I kind of just go up to the rail that I marked, move back a little bit, and then kind of sight down the welder. You're not going to get it perfect, but as long as it's close, it looks fine. Structurally, it really doesn't matter. Okay, here's it welded in. Each receiver seems to vary a little bit, but you get better and better at it. We'll go throw this one on the mill and drill the rest of the holes, and then we'll heat treat it.